Hello, so in this video I'm going to run through briefly the basic concepts when dealing with data that is discrete, that is specific values and not continuous. So as an example, I'm going to use the top dataset shown up here, and this video sort of runs through how to deal with it when you do it by hand. So there's going to be another video explaining how to deal with it using a calculator. So first off, if you do it by hand, what you would want to start to do is rewrite this in order, so it's increasing numerical order. That way everything is much nicer. The next thing we're going to do is talk about the middle of a dataset, and there's actually 3 different ways of finding the middle, sort of. And one is the easiest way, and that is the mode. And the mode is just defined as the number that occurs most frequently. So in this case, 4 is the mode because 4 occurs 3 times, whereas every other data point occurs less than 3 times. If, for instance, we had 5 also occurred 3 times, then we would call the dataset bimodal, bi as in 2. If we had 3 data values that occurred the most, then it would be trimodal and so on. The next thing is the mean, or the average, which can be technically written as this fraction, where n is the number of data points. So in this case, n is 9, because we have 9 data points. And this is just sigma notation for summing up all the values. So we would add all the values, divide by 9, because we have 9 data points, and then we get the average, which is 6 in this case. Another way of doing it is using this fraction, where what we've done is actually we've just grouped them together. So instead of saying 4 plus 4 plus 4, we're going to say that we have 1 occurrence of the value 2, 3 occurrences of the value 4, and so on. And of course, we divide by 9 again, and we get the same value. So in this case, this is going to be easier, but if I have large data sets, I don't want to write 2 plus 2 plus 2 like 117 times. Then it's easier to say 117 times 2. So these give the same, and depending on how large the dataset is, sometimes the top one's preferred, sometimes the bottom one's preferred. The last thing we can call the middle is the median, and that is basically just when we have arranged these in numerical order, we just count towards the middle. So in this case, 5 is the middle value because we have 1, 2, 3, 4, 5 from the left, 1, 2, 3, 4, 5 from the right. So this is the middle data value, so that's the median. Right, next thing we're going to talk about is spread. So that is a measure of how far spread out our data points is, how much they vary. We already seen the median, and from the median, this sort of divides our data sets into a lower part and an upper part. And in those 2 halves of the data set, we can also find the medians, and that's going to be the lower quartile. If I hit 2 values, in this case I have 1, 2, 3, 4 data points. If I count towards the middle, I'm going to hit 2 at once. What I do is I take the average of those 2. So in the top half of my data set, I'm going to hit 7 and 9. The average of 7 and 9 is going to be 8. So that's called the upper quartile. And then when I have these values, what you can do is you can calculate something called the range. And the range is just basically how far is it from the bottom to the top. So this is max minus minimum, and that's going to be 12, because from 2 to 14 there's a gap of 12. You can also do the interquartile range, which is the difference between the upper and lower quartiles. So that's going to be 4 in this case, because from 4 to 8 there is a gap of 4. And these are the basic 2, and then we're going to work with something called variance and standard deviation, but we're only going to do that using a calculator. We're not going to calculate that by hand because it's sort of a messy calculation. And I'm going to show how to do that in another video. Last but not least is something called the box and whisker plots, which, given this so-called 5-number summary, which is the minimum value, the lower quartile, the median, the upper quartile, and the maximum, you sort of do a visual representation of that, where you have the minimum here, draw a line, draw the box with the lower quartile, median, upper quartile, and then draw a line again up to the maximum. So this is called the 2 whiskers, the 2 sides here, and then this in the middle is called the box. And that's why it's called box and whisker plot. Now, what you need to know here is that every time I go from one point to another, that sort of represents 25%. So the lowest 25% of this data set is going to be between 2 and 4. The next 25 is between 4 and 5, then 5 to 8, and the top 25% is going to be between 8 and 14. So the median sort of divides our data set into lower 50% and higher 50%. Last thing is the outliers, which are defined as such. This looks really complicated, but it's not. It's just, I take the interquartile range, I make that 1.5 times as large, and then from the box, I sort of go down that value or up that value. And then if I have data points further out than those values, it's called outliers. So for instance, our interquartile range from 4 to 8 was 4. 1.5 times that is 6. So if I went down from the bottom of the box, 6 down, I would get down to -2 over here. And I don't have any data points that's below -2, so there's no outliers on the lower half. Above, I would start from 8, I would do the 1.5 interquartile range, which was 6. 1, 2, 3, 4, 5, 6, I end up at 14. So 14 is just within the limit. If I had any data point that was above 14, that would be marked as an outlier. And you would mark that with just a dot instead of extending this whisker. 14 is okay, that's the boundary. So in this case, I don't have any outliers. But if the last data point was 15, that would have been an outlier. And that is it, except for one little thing, and that is if I have an even amount of data points, I have to be careful about something, which is when I try to find the median, I am going to find 2 values, and in this case, the median is going to be between those, right? So that's going to be the average of 4 and 5, which is 4.5. Now the thing is, when I want to find the lower quartile and the upper quartile, a lot of students sort of think, well, this 4 has already been used, but think of this as this line is the median. So these 4 values here, including this, is going to make up the lower part of the data set. And this 5 is going to be included in the upper part of the data set. So in this case, I'm going to hit 4 and 4 and 5 and 7 when I want to hit the lower and upper quartiles. Some students think the 4 has been used, so it's just going to go like this. Only these 3 values are going to be used. And that's not correct. So that's it for now. Thank you. Have fun.